Morning, everybody, and welcome to this screencast on measures of spread. So this screencast is the final lesson, I guess you could say, in this particular series on measures of spread. So there are three things that we need to accomplish through the video and through your study, and that is the topic of percentile, z-scores, and outliers. So in order to get things going, I highly recommend that you do take a look at these two short videos on YouTube concerning the topic of baby birth weight and height because it is a commonly used context for percentile and a great example that can be applicable to a variety of people, perhaps people within your family, or perhaps for yourself in 10 or more years looking into the future. Okay, those links are not active within this file. Nor are they active in terms of where they're posted on YouTube. So with OneNote open, I have included those links here, okay, as well as the note template. So let's get back to figuring this out. So I'm assuming you've already gone through, viewed baby birth weight and height and are already thinking about the significance of the term or concept percentile. So let's open this up by examining a problem. So a newborn is found to be in the 5th percentile for weight and the 95th percentile for height. What I'm wondering is, what does that say about this particular baby in terms of weight and height relative to all others? So having thought about it a little bit, and oftentimes it's good to pause the video, do some thinking for yourself, and then play on to see if your thinking holds true to what is here. And in terms of percentile, we can look at it this way. The 5th percentile means that 95% of babies will weigh more than this particular baby. Whereas the 95th percentile for height would mean that 5% of all babies are taller. So in conclusion, that data suggests that the baby is tall and thin. And you might have been able to see some of that or captured some of that in the second video on YouTube where they were showing you a percentile growth curve. So based on the videos, based on this particular problem, we can start to formulate a definition for percentile. So then a percentile shows us or indicates the position of a score. So a particular score in a distribution ranging from 1 to 99. So from the first up to the 99th percentile. Percentiles divide an ordered set of data into 100 intervals, and those intervals then contain equal amounts of data. You've already seen examples of percentile. So Q1, the first quartile, the median, the second quartile, and the upper third quartile. Those are examples of specific percentiles. Although the quartiles divide a data set into 4 intervals, while percentiles chunk the data into 100 intervals. So with an example, with a definition in hand, we can go ahead and apply that to a particular problem. And one that we often apply it to, especially in a high school and senior setting, are marks or test scores. So here are the scores for 20 students on a particular test out of 40, and we have 4 parts to deal with. Part A is asking about the 80th percentile. So if a student scores at the 80th percentile, what is the student's raw score? So before you dig in, again, reflect upon what the meaning is of percentile. So the student scores at the 80th percentile. So that means that the student scores at a particular percentage, or particular mark, I should say in this case, because we're looking for a raw score. That's the score out of 40. particular mark below which you would find the remaining 80% of those marks. So in terms of setting up a solution, why don't we go ahead and think this through here a little bit. So because there are 20 scores, the 80th percentile, which means that 80% of 20, that's 16 scores. Those 16 scores would have to be captured in that interval. So we'd have 16 scores below the 80th percentile, while 4 scores would lie above it. So if you go through that list of data, and let me trace this out here a little bit more. So I'm going to highlight particular values. So if you work your way up to here, this would be your 16th datum, and your 17th is here. So we would need to locate the raw score of 35, which is also, in this case, the 80th percentile. So below that particular raw score, we'll end up finding 80% of scores. So the problem develops into a few more parts. So part B is now asking us about the raw score and then working backwards to find the percentile. So you can see within this data set that there are a couple of 30s, and they lie right in the midst, or the middle of the data set. So if we were to split that in half, that data set, we would ensure that a score of 30 would lie within the bottom and the top of the data set. So if we split that into 2 equal intervals and call it the 50th percentile. So 30, the first one would be in the bottom 50, the second in the top. And last but not least, let's have a look here at C and D. So in order to make room for this, I will be taking part A and B out of the way. Feel free to rewind if you need to. So with a 70th percentile, if a student scores in that percentile, what percent did they get? So that's different than raw score. So there will be one added step. And at this point in time, what I would suggest is do take a moment to pause. Much like a lesson in class, we often do a little bit of thinking along the way. So by pausing, give yourself a chance to process C and D, and then go ahead and see what your thinking says about answers to those problems. Well, here's part C. So the 70th percentile is going to capture 70% of that data. So that's 14 pieces of data. So if you look through the data set, the 14th datum is 33. And so that score of 33 would then result in a percentage of 82.5, given the fact that the test is out of 40 marks. And last but not least, part D, having put some thought towards that before revealing a solution, if you get a 60 on the test, we know now that 60% is going to be a particular raw score. That's a score of 24, or 24 out of 40. If you go back to the list of data, you'll see that, let's see if I can get that here. You're going to see that 24 is the 6th score on that list. Okay, so if we want to capture the 6th score, so that is to divide the data set up into, so I'm just going to put a line there to indicate a break, or where the percentile would be found, or would represent those two intervals. So we would have to place it at the 6.5 or 32.5 percentile. So we'd have to look between 24 and 25 in order to create two intervals. The first interval capturing 6 data, whereas the upper interval capturing 14. So again, the percentile would be at the 6.5 position or the 6.5 datum, although that particular datum isn't there, but it's at that particular position. So at this point in time, what I'm thinking of doing is closing off this particular screencast, keeping it short, and then packaging the remaining material, so Z-scores and outliers, into a follow-up video.